Okay, so this one, we're going to use some trig identities to change it. If I look at the first one, I need a half out the front, so I can add a 2. So 2 sin x cos x, hopefully you recognise 2 sin x cos x. So we've got half, we've got the x, and we've got sine 2x dx there. That should make it easier. So if we again integrate by parts here, we're going to integrate sine 2x becomes negative cos 2x divided by 2, and we're going to leave the x where it is, minus, so we've got negative cos 2x over 2. I'm going to change that to a plus now. Let's put a 1 over 2, so plus 1 over 2, let me make room there. So that becomes a negative, and we've got half cos 2x, and we're differentiating the x, so it just becomes cos 2x dx. Now this is, I'll just put it out here for the moment. So this is between 0 and I think pi on 2. So actually we could, because that's a half outside of everything, we could actually do bit by bit. So I could do that quarter and make it a negative quarter, and do the x times cos x. I might just write it x cos 2x between 0 and pi on 2. And then you've got, so this is where it can easily go wrong, half times a half, so we've got a quarter here. All right, so cos 2x we know goes to sine 2x when we integrate, but divided by 2. And again, that's between 0 and pi on 2. So negative a quarter. All right, so when I put cos 2 lots of pi on 2s, it's just cos pi. Cos pi is negative 1, so we've got negative pi on 2. When we put 0 in, we just get 0. Okay, plus I'll put 1 on 8 there, because you know I can't deal with those constants. So 2 lots of pi on 2 will just be pi, sine pi is 0. If I put 0 in, sine 0, still 0. So nothing over there. So I'm just getting negative times a negative, so pi on 4 2s are 8, which is correct, thank goodness. All right, so let's try B. What identity are we going to use for B? For B, we've got sine squared. We don't like sine squared, but we know that one. So we've got sine, remember sine squared x is just a half 1 minus cos 2x. You can use your double angle formulas and rearrange to get that. So our integral becomes, if we put our, we'll put that a half out the front. So instead of the inside the integral, so we've still got the x and the sine squared up at the other part. If I multiply that x through the bracket, I get 1 lot of x minus x cos 2x dx. So this is the new integral, and just makes it a little bit easier. You can say I'm just going to get x squared on 2 for that first bit, 0 to pi on 2, and then if I separate out the integrals, I've still got a half, so I'm going to say minus a half the integral of x cos 2x dx here, just to separate it out a bit. So you can see here, I'm going to put a quarter out the front. We're going to get pi squared on 4 minus 0 there. All right, so here we've got minus a half, and we're going to integrate by parts. So cos, we're going to make cos into sine, so integrating, so sine 2x over 2, and still times it by just that x. All right, so we've integrated the sine 2x over 2, and the x will just become 1. So now that's, I'll just put that on the outside, just easier for the moment. So here we're going to get pi squared on 16. All right, so we're going to get a minus a quarter, a sine 2x times x of 0 to pi on 2, and then we're going to get a plus a quarter this integral sine 2x. Now when you integrate sine 2x, you get minus cos 2x on 2. So we've got the pi squared on 16, which looks like what we want if we look up here. If we put in pi on 2, we've got sine double that, so that's sine pi. Now sine pi is 0, so you're going to get negative a quarter, you're going to get a 0 there. When you sub in 0, you're still going to get 0 because you're timesing by that x value there, which is 0. Alright, so that middle term gives us nothing. Let's put the minus out the front with the 1 on 8. 4 2's are 8, and just use the cos 2x. So we're going to get cos of pi, cos of pi is negative 1, and then get cos of 0, sorry, that should be a negative 1, minus cos of 0 is 1. There we go. So we're going to get pi squared on 16 there. We're going to get a 0. Minus 1 is minus 2. Minus minus is a positive. We're going to get 2 on 8, which is a quarter. All right, so it's if they want it like so it's a show that kind of question. So they've put 1 on 16 out the front. So let's put 1 on 16 out the front, which should give us pi squared plus, so a quarter is 4 on 16. So we'll just put 4 there. And then we've got the answer we want. All right, so moving right along to C. Let's have a look at what C is. All right, so C, we've got x with a tan squared x. Let's see how we go with this one. So tan squared we can change to sec squared minus 1. Will that help us? So if I do that, I've got x times sec squared, and so let's do that, x times sec squared x minus 1, so minus x. And 0 to pi on 4, 0 to pi on 4. All right, so if we look at the first one, we can integrate sec squared back to tan x and leave the x minus, I'll do this, 0 to pi on 4. So minus, what did we integrate? We integrated the tan x. So there's the tan x. Now we differentiate the x, so it just becomes tan x dx. All right, and then if we integrate the minus the x, we get x squared on 2. So that's just a straight integration. Okay, so tan pi on 4 we know is 1, and we've got times x, so it's pi on 4, 1 times pi on 4. Tan 0, 0. So we just got pi on 4 minus 0, so just pi on 4. Minus, all right, let's do tan x. Remember, tan is just sine on cos, sine x on cos x. And the derivative of cos x, is minus sine x. So if I make this a plus and put the minus here, you've got the derivative on top. So you can tell it's just going to be a log answer. So I'll do that in a second. Then we have over here minus, let's put the half out the front. So we've got the x squared, so pi squared on 16 minus the 0 squared there. So at the moment we've got the pi on 4. So here we're going to, now we've got just the log of cos x. And we've got it between 0 and pi on 4. Minus pi squared on 32. All right, are we looking close? There is a pi squared on 32 there, so that's good. So we've got the first two terms. We've got the pi on 4, we've got the minus pi squared on 32. So we've got the pi on the 4, we've got the minus pi squared on 32. So let's sub into the log. So cos 45 is 1 on root 2, so we're going to get log, what did I just say? 1 on root 2. And then we're going to sub in 0. Cos 0 is 1, so we've got minus log 1, which doesn't do much. All right, so got the first two terms. Now if you think of it, 1 on root 2 is 2 to the minus a half. If you have log to the 2 to the minus that, remember log 1 is just 0, so ignore that one. So this negative a half can come out the front if you want log 2. So you've got minus a half log 2. So now we've got all three terms. So we have shown that, no problem. All right, so let's then try D. Hope that helped. All right, so for D, we've got cos squared minus sine squared, and we know that's just cos 2x, right? So really we're just dealing with x squared and then cos 2x in our integral. All right, so if we integrate the cos 2x, we're going to get sine 2x, and we're going to divide by the 2, so I'll put that up front. And then we're timesing by our x squared, so we're leaving our x squared as is. And then we're going to go minus, so we've integrated, so we got the sine 2x on 2. And we're going to differentiate the x squared, so we get a 2x. I'm going to times the x there, and I'm going to put the 2 out the front. So 2x dx there. All right, so over here we've got limits as well. Our limits are 0 to pi and 0 to pi. Okay, so if I put 0 in, nothing gets 0. But if I put pi in, let's have a look. We get sine of 2 pi, which is 0. So that whole first bracket again is giving us 0. So let us not worry about that one. Then we've got minus 1 lot of this integral. All right, so that's all we're dealing with, minus, and I'll just rewrite it, 1 lot of sine 2x times x dx. So we need to do this again. So let's have a go. So we've got minus out the front. We are integrating sine 2x. Sine 2x becomes minus cos 2x on 2. So minus cos 2x on 2. We're going to leave the x there. Minus, now it's minus cos 2x on 2. So I'm going to make it on 2. And that minus minus becomes a plus. And the x differentiates to 1. So I'm just going to get dx there. So just remember though this minus out the front. So I'm going to have to, if I break it up, I'm going to have to times the minus by that positive a half. So over here I'm getting a minus minus is a positive, so I'm going cos 2x times x on 2 between 0 and pi. And using that green line, I've got minus a half of the integral of cos 2x. Now, if I integrate cos 2x, I know I get sine 2x on 2. All right, so let's do that. So when I put 0 in, I'm going to be minusing 0 because it's times 0 times x. All right, when I put pi in, so cos 2 pi is 1 times pi. So I'm going to get 0 minus pi. Is that what I get? So, pi, I'm going to put pi in first. Whoops. It's because I tried to cheat. When I put pi in first, I get cos 2 pi is 1 times pi. So I get pi minus 0. All right, this one I'm going to put a quarter here. So for this one, again, you're just going to get 0 minus 0. Nice. So we're going to end up with pi on 2, which is what we wanted. So good.